Alright, we'll continue from where we left. Okay, let's solve another problem. The next problem is if a particle moves along a path where x is equal to t cube minus 4t, comma y is equal to t square plus 4t, and say z is equal to 8t square minus 3 times t cube. All right, the question is find components of acceleration at t equal to 2 along the tangent and normal. So you see here, it's actually a hybrid type of question which includes almost everything we discussed so far. X, Y, Z components have been given. We are supposed to calculate the acceleration first, then the component of acceleration along tangent and normal. So we need tangent as well as normal first, right, to calculate this component. All right, so to start with, let us find out what is this r. R is equal to, as per the standard definition, this is x into I cap plus y into j cap plus z into k cap. So when we substitute this, it becomes t cube minus 4t times I cap plus this is t square plus 4t times j cap plus the last component, that is z, which is 8 times t square minus 3 times t cube times k cap. Alright, so this is r. Now when we have r, we can find the velocity component by simply performing what is called as a differentiation. So this is dr by dt. So just look at the above equation so that we can differentiate. So t cube I have, this becomes 3 times t square minus 4 into I cap. All right, plus the second component t square is there, which becomes 2t plus 4 times j cap. Then we have the last term, that is plus 8 into 2 is 16 times t minus 3 into 3 9 times t square into k cap. Okay, so we got the velocity now. Then we need acceleration. So a is equal to, this is differentiation of v vector by with respect to time. So differentiating this above equation, you can see that 3t square I have, which is 6t, so 4 becomes equal to 0 into I cap plus there is a 2t, differentiation is simply 2 into j cap. Then I have the last component coming up, that is 2t, sorry, 16t, 16t becomes 16 minus 9 into 2, that is 18 times t times k cap. Okay, we got this. Now you see the question says that we need to find the components of acceleration at t equal to 2. So what we do, we'll try to calculate the acceleration and velocity. All right, so we'll do that calculation first. So that means let's write v at t equal to 2 is equal to, I'm simply going to substitute t equal to 2 in the equation of velocity, so that you can see that this is 3 times t square, so 2 square minus 4 times this is I cap plus this is 2 into 2 minus 4 times j cap plus the 16 times 16 into 2 minus 9 into 2 square k cap. Okay, now so this means this is equal to 3 into 4, 12, 12 minus 4, so that is equal to 8. This is 8 I cap. Then 2 into 2, 4. My mistake, this is a plus. Alright, so this is 2 into 2 plus 4. So 4 plus 4, this is 8 into j cap, minus 16 into 2 is 32. 9 into 4 is 36. So 36 minus 36 plus 32 is minus 4 into k cap. So you can see that this is the velocity at t equal to 2. Similarly, let's calculate the acceleration. Okay, this is a at t equal to 2. So that means 6 into 2 times I cap plus 2 into j cap plus this is 16 minus 18 into 2 times k cap. So this becomes now 6 into 2 is 12 I cap plus 2 j cap. This is minus 16 and 36 is 20, so minus 20 times k cap. All right, so this is what is the vector a at t equal to 2. Now see, the velocity is along the tangent to the curve. So the question is, right, you can see that the let me explain this once again. Let us say that the particular object or a particle is moving in this curve. Okay, at a particular point, this is corresponding to the point at t equal to 2, let's assume. Now if you look at the velocity, always the velocity is pointed in this direction. Velocity is a tangent. Okay, so let me write that again properly. So let's denote the velocity. So this is the velocity. This is the velocity component. So you can see that velocity is a tangent, right? Now the question is, find the component of acceleration in the direction of velocity and also in the direction perpendicular. So we need to find two things now. One is the acceleration component, right? A, this is along tangent, and another component is this, that is A along normal. So we need to find these two components now. So already we know the component which is along, which is the tangent. Tangent is v. Okay, so first point, this is my answer, right? The answer, we are trying to complete our answer now. So the first part is like this. I'll write an explanation for you. This is velocity is along the tangent, right? Since the velocity is along tangent, this implies, right, component along tangent is equal to the component of vector A, that is acceleration, along v vector. So a component of one vector along other is nothing but you need to find a unit vector. Okay, so that is, let's find a n cap which is equal to vector v divided by magnitude of that vector. So what is a vector v? Let's write the vector v now. Just now we have written this is 8i plus 8j minus 4k whole divided by square root of, this is 8 square plus 8 square plus 4 square. Alright, so this implies the n cap is equal to 8i plus 8j minus 4k divided by, this is root of 64 plus 64 plus 16. Okay, let's calculate that value now. So 64 plus 64 plus 16 is 144. So there is a proper answer for that. This is 12. So I can write this as, okay, I'll write n cap is equal to 1 by 12 times. This is 8I cap plus 8j cap minus 4 into k cap. Okay, this is the n cap. Now I need to find out the component of A. Therefore, component of A vector along V vector is nothing but the vector A dot n cap. Right? We already know this from the basics. So let's try to substitute the values now. So that is equal to, if you remember the vector A, acceleration, that is given by 12 I cap plus 2 times j cap minus 20 times k cap. This dot, the above answer, that is 1 by 12 into this is 8I plus 8j minus 4k. So this is equal to, I'll write the 1 by 12 outside. This is the components of I, we will multiply together, that is 12 into 8 plus next 2 into 8 minus of minus is plus 20 into 4. So you can see that this is 1 by 12 into, this is 96, this is 16, this is 80. So the sum now comes to be equal to 96 plus 16 plus 80 comes to be 192 divided by 12. So it's a whole number. So 16 is the answer. So we can see that this is the component of acceleration in the direction of the tangent to the curve. Okay. Now, just recall another point, that component of one vector perpendicular to that vector. Okay. So that is, let's write this component. This is the next part of the answer. Component along normal, right? That is equal to, let's go back and check the equation which we are going to use. Okay, say this part, right? I'm talking about this particular equation. Component of a vector perpendicular to the other vector. Now the other vector is v, velocity. Perpendicular to velocity is what I'm searching for. That is nothing but a vector into this component into n cap. This is what I'm supposed to do. Again, there is a magnitude to be calculated. Okay, so let's write that now. This is equal to, this is vector A, this is vector A minus a vector dot n cap into n cap, and I need to take its magnitude. Okay, so let us simplify this now. This is equal to, first let us write the vector A itself, right? So what is vector A? Vector A is, this is 12 I cap plus 2 times j cap minus 20 times k cap minus, okay, I have to subtract. See, there is a dot n cap. A dot n cap is the previous answer, so that is 16. Okay, 16 into the n cap. N cap is, you can see the answer. N cap is nothing but, this is 1 by 12 into 8I plus 8j. This is 8I cap plus 8j cap minus 4 into k cap. Okay, so this means I just have to calculate this answer and I need to take its magnitude. Okay, so that means let's simplify this further. This is equal to magnitude 12i plus 2j minus 20k minus, let's take the 16 as it is. I'll cancel this with the 4 outside. So when you take 4 outside from the above bracket, 4 cancels with 12 as 3 into, see this is 4 goes out, so 2i cap plus 2j cap minus k cap. I need to take its magnitude. Alright, now let's simplify this. 12, I can take the 1 by 3 outside now. Let's take the 1 by 3 outside so that the whole thing becomes easy for us. So when I take 3 outside, this is magnitude of 12 minus 16 by 3 is actually 4 by 3. This is 4 by 3 I cap minus, this is 2, 16 by 3 into 2 is 32 by 3 plus 2 becomes minus 26 by 3 into j cap. Then minus 20 plus 16 by 3 is minus 44 by 3 k cap. Okay, in the next step, this is equal to, I need the magnitude, so this is nothing but square root of this is 4 by 3 square minus 26 by 3 square, sorry, not minus, plus 44 by 3 square under root. I can see that the 1 by 3 square is there. I can take it out. 1 by 3 into root of, now this is 4 square plus 26 square plus 44 square. Okay, so let's calculate that. This is 1 by 3 into root of 2628. So the final answer that I'm getting here is 2 root 73 after simplification. All right. So this is a pretty important type of problem, right? Where we get many questions on this. All right, let's go further. Solving another question of a same type. This is very important. So if a particle moves along a path defined by x equal to t square, y is equal to minus t cube, and say z is equal to t to the power 4, then find the tangential and normal components of acceleration at t is equal to 1 second. Okay, this is the question. All right. So initially you can see that our objective is to find the normal component of acceleration, but I need to write the vector first. Okay, vector is nothing but this is x into I cap plus y into j cap plus z into k cap. This means x, y, z values have already been given. So this is t square into I minus t cube into j plus this is t to the power 4 into k cap. I got this now. So this is the position vector of the particle which is moving around some curve. Okay. Now what we can find from this? I can directly find the velocity by simply differentiating. That is dr by dt. So this is differentiate this. There is a r square. So r square sorry t square becomes 2t. 2t into I cap minus 3t square into j cap plus 4 times t cube into k cap. This is v. All right. Then similarly, I can find the acceleration, which is differentiation of v with respect to time. So what is dv by dt? Differentiate the above equation. 2t becomes simply 2 into I cap minus 3t square becomes 6t into j cap, right? 4t cube becomes plus 12t square into k cap. Now what is my next intention? I have to find the velocity and acceleration at the given time. So why it is supposed to be substituted at given time? Because I want at exactly that moment in time axis, I want to find what is velocity, what is the component of acceleration along velocity, what is the component of acceleration perpendicular to velocity. So we need to calculate the v vector at t equal to 1. That means it is 2 times t. So t can be substituted as 2 into 1 into I cap minus this is 3 into 1 square into j cap plus this is 4 into 1 cube times k cap. That is equal to 2 I cap minus 3 j cap plus 4 k cap. 2 minus 3 I j plus 4 k cap. Okay, this is the velocity. I need to calculate acceleration at t equal to 1. That means substitute the same thing. So this is 2 I cap minus 6 into 1 j cap plus 12 into 1 square k cap. So you know that this answer is now 2i minus 6j plus 12 k cap. Now you see that I need to find the unit vector so that I can find out the component of A along V. That's what is asked. So to find the component of vector A along vector V, this is my tangential component, right? So what do? You calculate a n cap. N cap is equal to vector V divided by sorry, let me just correct. I wrote the okay, this is vector V divided by magnitude of vector V. So this is V vector divided by magnitude of V vector. So how do you find a V vector? Let's substitute this as it is. This is 2 I cap minus 3 times j cap plus 4 times k cap whole divided by square root of this is 2 square 4 plus 3 square 9 plus 4 square that is 16. Okay, 16 plus 10 plus 3 is 29. Okay, so I can write it in the following fashion. Therefore, n cap is equal to this is 2 I cap minus 3 j cap plus 4 cap divided by root of 29. Okay, so therefore the final answer for this part of the question, the required component of A vector along v vector is nothing but this is vector A dot n cap. It's a dot product. Okay, so this is equal to, let's write the vector A now. So vector A is acceleration, that is 2i cap minus 6j cap plus 12k cap. Multiply that with it's not cross, it's a dot product, sorry. Simply write a dot over there. Dot this is 2i cap minus 3j cap plus 4k cap by root of 29. So the required component is, this is 2 into 2, so that is 4 plus 18 plus 48 by root of 29. 48 plus 18 is 66 plus 4, 70. 70 by root of 29 is the answer. So this is the component of A along V. Okay, now the next part of the question is to find out the component of vector A perpendicular. In the sense it is normal, okay, perpendicular to V. That is given by magnitude of A vector minus A vector dot n cap into n cap. This is the equation. So let us substitute everything from whatever we had already calculated, right? So this is magnitude of, first let us write vector A. Vector A is, this is 2i cap minus 6 into j cap plus 12 times k cap. This is A. Minus, I need to write A dot n. Just now we found that the A dot n is 70 by 20, root 29. 70 by root of 29 into, write the n cap. So n cap is nothing but n cap. You can see and write the answer as, okay, this is 2i minus 3j plus 4k whole divided by root of 29. Its magnitude is what I want to calculate now. So this can be written now as, let's take the 1 by 20, root 29 becomes 1 by 29, okay, into, now all, okay, so let me do it in this way. Okay, instead of taking this common, let me substitute the value. So 2 into 70 into 2 by 29 becomes minus 140. So this is minus 82 by 29 I cap. Okay, then minus 6 plus 21 by this is plus 36 by 29. Then we have 12. 7 into 4 into 29 is equal to plus 68 by 29 into k cap. All right, now so let us substitute. This means I need to take its magnitude, so I'll take the 1 by 29 outside, or even I can do it in this way. This is square root of I'll take the 29 outside. I'll keep this as 1 by 29. This is 82 square plus 36 square plus 68 square. All right. So this means the root of 12644 by 29. Okay, this is the answer. We can simplify and get a much simpler answer, but anyway, this is the final answer. Yeah, sure, we'll be sharing this one. The next question is, if say vector r is equal to vector a into e to the power n into t plus b vector into e to the minus n into t, right? Then show that this is a theorem. This is d square vector r by dt square minus n square times vector r is equal to 0. All right, so this is the question. Right, so we'll start with r. So r, already r is given, so r is equal to, this is vector a into e to the nt plus this is vector b into e to the minus nt. Are you okay? Now let's differentiate. So first part is dr by dt. So what is dr by dt? You need to differentiate the given equation, right? So we'll try to do it in this fashion, right? Here you see that here one point is given, uh, that is, okay, let me write here, this is vector a comma vector b are constant vectors, not different, not a function of time. Okay, and you see that the n value which is given here, n is a constant. So this is what is given, right? Normally with the question, they will definitely mention this. Okay, so dr by dt is now you see that the a vector is a constant. I don't have to differentiate that. E to the nt is n into e to the n nt, right? Differentiation of e to the at is a into e to the power at. That's why. Okay, then similarly, I'm going to write the second part as this is plus b vector is a constant minus n e to the minus nt. Okay, this is my function, so I can write this as n a vector e to the nt minus n b vector e to the minus nt. Okay, this is the first differentiation. Now let's write the second differentiation of the same function. That is, I want to differentiate this once again. So d square r by dt square is equal to, once again you get differentiate, this is n square vector a e to the nt, this is plus, we can see that this is minus of minus, so plus n square vector b e to the minus nt. Okay, so what I do, I can see the n square constant here. This is vector a e to the nt plus vector b e to the minus nt. So you can see this part, you can compare. So this and this are same, which means I can write this is equal to n square into r. Okay, now take this to the left side. That means d square r by dt square minus n square r right hand side becomes equal to 0. So this is what they have asked to prove. Okay, I can go back and check, right? Then show that. You can see this is what they have asked to prove. And the same answer we are having here. Okay, that's the solution. Let's move on to the next question. All right, so this is another theorem. If dA by dt is equal to some w vector cross a vector, okay, and there is another value given, that is dB vector by dt is equal to w vector cross b vector. Then we need to show that d by dt of vector a cross vector b is equal to, this is w vector cross a vector cross b vector. So this is the question now. Okay, now let's try to write, let's start with the definition, what we already know. Okay, so that is, we know something. That is, if you want to perform d by dt of vector a cross vector b, then what we'll write? This is nothing but, we already know this is equal to, keep the first vector, take a cross product of differentiation of the second vector, that is db by dt, plus this is dA by dt cross vector b. Alright, but if you look at the given data, what is given data? dA by dt is w cross A, dB by dt is w cross B, correct? So this is equal to, now we can write it as vector A cross dB by dt. You can see that dB by dt is w cross B, right? So I am going to replace this as w vector cross b vector. So how you are writing? You can see that there is a dB by dt and dB by dt is given as w cross b. Okay, then in the next part, so there is a plus sign after this. I am writing a plus. Now you see that there is a dA by dt. So the dA by dt is given as w cross a. So let us substitute that here. So this is w vector cross a vector cross this, that is b vector. Alright, so now I'm going to hold on to this. On the left hand side I have d by dt of, this is d by dt of vector a cross vector b equal to this. Let's hold on to this. And in the next step I'm going to use something very basic from vector algebra. Right, we also know that this is from the basics. It says that if you have a vector a cross vector b cross vector c, this is equal to the dot, you can write the cross product in terms of dot product. Okay, so cross product in terms of dot product, this is vector a dot vector c into vector b minus vector a dot vector b into c vector. This is the first thing, or which we know. I will write another version of the same equation. This is also useful now. That is, if you have vector a cross vector b cross vector c, then this can be written in the following fashion. This is vector A dot vector C times B vector minus this is B vector dot C vector times A vector. So the difference you can see here, this is what I am going to call equation number 2. Right? Let me substitute the in equation number 2 in equation 1. I am trying to convert the equation 2 in the above said format. Okay, so that means I'll just show you what is the equation number 1 as well. Okay, so I'm substituting this now. So this is 2 in 1. That means if you have d by dt of vector A cross vector B is equal to, okay, you can see that this first term in this equation, this is what I'm writing now. I'll try to write that inside is flower bracket. So this is A cross, see this is the format I have now. So this is A cross B cross C. That is, this looks like this for me. In a sense, I am going to write something similar to this side. Alright, so that is equal to, and I'll write, now you can see that this is bracket vector A dot vector B. Instead of C I have, right, I have W, so I'll write the W vector minus, once again, vector A dot vector W times B vector. Okay, so this is the first part. Then I have the second term coming up, that is plus, we'll write another bracket. See, this part looks like this form. So A is W vector, B is A vector, C is a B vector, right? I have to make those changes when I write this particular term. So that is, now this is W vector dot B vector times A vector minus vector A dot vector B W vector is what I write here. So I can see inside this, whatever I have inside this bracket, A vector dot W vector into B vector, W vector into B into this. So I can see that these two terms get cancelled. This is positive, this is a negative term. Are you okay? So let's write that. This is equal to, now what I get the remaining term I'm going to write. The positive term I'll write first. So this is W vector dot B vector times A vector minus A vector dot W vector W vector into B vector. Okay, so compare this with this equation, right? I'll highlight with a color. So if I compare this with this, all right, this is how it looks like. So instead of C I have to write a B, instead of A I have to write a W, and instead of B I have A. So this is nothing but, so this is equal to, right, instead of A I have W, so this is W vector, cross, instead of B I have A, so this is A vector cross B vector. So on the left hand side I have, right, d by dt of vector A cross vector B is this. Alright, just see, this is what has been asked and we got the answer. Please verify this, and if you have any doubt, let me know. Okay, then the next question, there is another theorem important. This also has appeared in many of the question papers. Alright, so this is show that vector A cross d square b vector by dt square minus d square a vector by dt square cross b vector is equal to d by dt of a vector cross dv vector by dt minus this is dA vector by dt cross b vector. Alright, so here we use a tactic where we start from the RHS and we'll come to the left hand side. Alright, so RHS is d by dt of vector A cross dv by dt minus dA vector by dt cross b vector. So this is equal to, now you can see that there is a d by dt outside the bracket, which is a linear operator. You can apply this to the individual terms. Alright, so that is, I'm going to write in this way. So this is d by dt of, first let me write a vector cross db by dt first term minus d by dt of the second term, that is dA by dt cross this is b vector. Now see, the differentiation is being applied to a cross product, so I know that what happens with the cross product when you apply this. So this is nothing but keep the first function as it is cross differentiation of the second term. What is that differentiation of second term? That is d by dt of db by dt, which is d square b by dt square, first term. Then what happens? Keep the first function as it is, differentiate the first function. What is that? This is dA by dt cross, keep the second function as it is, which is dB by dt. Okay, this is the complete expansion of the first term. Alright, then we'll go to the second term now, minus, I'll write inside the bracket. So differentiation of some cross product is nothing but keep the first function is, in this case, this is dA by dt, cross differentiation of the second term, which is dB vector by dt, right? Then I have a plus, it's a continuation of the same square bracket. Differentiate the first term. Already there is a d by dt, it's d by dt of d by dt, so I can write d square a vector by dt square cross dB by dt. So let us expand this now. So when you expand, so this is equal to, let's say this is vector A cross d square b by dt square plus dA by dt cross dB by dt minus dA vector by dt cross dB vector by dt minus d square a vector by dt square cross dB by dt. So I can see these two terms getting cancelled because one is positive, one is negative. So other than that, whatever is left over, we'll write it once again. So this is vector A. I think I just wrote one mistake here. See, this is just B. Sorry, let me make a correction. This is simply B. All right, because you can see above here Over here, this is written as simply B vector. So it should come as simply B. Okay. This is vector A. I'll correct this. This is vector B now. This is also simply B. So this final answer, A vector cross D square d by dt square minus d square A vector by dt square cross B vector. Alright, let's now compare this with the given question. You can see that on the left hand side I have the same thing, correct? So for that reason, now our final answer becomes equal to this itself is the left hand side. Hence, this is the proof.